3D printing. It's been around a while. Used to be a tool for car companies or just a way to build prototypes. But recently, 3D printers have become popular at the consumer level. Now, we've been told they can be the new way to build homes, create food, or even body organs. In fact, in last year's State of the Union, President Obama stated it has the potential to revolutionize the way we do almost everything. That could just be a grandiose claim, or is it the new reality? Well, let's find out together on Best of Our Knowledge. All right, today we're talking about 3D printing and its relevance to our lives. I'm Steve Overmyer, and I'm proud and honored to be joined by such a distinguished panel of guests to talk about this topic. We start at the end there. Buel is the Director of Mechanical Engineering for Makerbot. Bill, thanks so much for joining us. I appreciate that. Erica Orange, the Vice President of Weiner, Edrich, and Brown, one of the world's foremost futurist consulting groups. And Piers Fox is the founder and editor-in-chief of creative business news site psfk.com. Piers,
good to be here.
Thank you so much. I really appreciate you guys here to talk a little bit about 3D printing. And 3D printing, I think we just start from the ground up. I mean, that's how 3D printing is born, right? I mean, it is additive manufacturing. It is adding something layer upon layer as opposed to, I guess, subtractive manufacturing where you cut something out. Bill, I'm going to start with you. Could you kind of maybe simplify some of the key elements of 3D printing for us?
Certainly. Well, you did say it. So additive manufacturing is adding material as opposed to subtracting it. So traditional manufacturing, what you would do is you would take a piece of metal or a piece of substrate and you would take material away and you'd end up with the product that you wanted in the end. With additive manufacturing, what you do is you break this product down just like, say, this cup here, where you can break this down into a whole bunch of layers. And those layers are very small, in the order of 100 microns, or about the thickness of your hair. And what happens is the 3D printer lays down a bit of material, whether it's plastic or metal or any other material that you want to print, layer by layer, and builds up your model one piece at a time.
Yeah. How is this relevant to our lives right now? How is it relevant to the audience's lives, the consumer level 3D printers?
To me, one of the most exciting things about this technology is that because at the heart of it, as you said, Steve, it's nothing new, but it's leading to the democratization of innovation. And because, like so many technologies, things become more commoditized and they become more available on the consumer level. The ability for people to have access to this technology and really use this as a springboard to create their own things, and at a price point that's now a lot more palatable, starts becoming very, very interesting.
I think it's beginning a new industrial revolution. I think it's providing access to a whole new range of products and services. I think, and we're already being touched by these products, whether we know it. You know, the braces in our teeth are 3D printed. Car parts are 3D printed. So there's things around us already that are being created by this process.
It's all about empowerment. And so previously, before 3D printers, 3D printing was only accessible via very expensive 3D printers. Now that we have desktop models that are very affordable, now it's accessible to everybody. And so you don't have to be a mechanical engineer, and here's why. Because there's so many engineers, designers out there that are putting items on the internet for free for you to download. In addition to that, there's people that are creating customizable items. So you can actually download something from the internet, customize it, without having any mechanical engineering skills.
And Thingiverse.com, run by Makerbot, is basically a place where people can go and share their downloaded schematics and share it with the universe. So let's take a look at some of the things that are on Thingiverse and see some of the things that people have thought of. Now, these things obviously are at different scales as well. So if you ever wanted a T-Rex helmet, or if you want a helmet that looks like a T-Rex. Actually, you know what? I'm still looking for, I want to create like a Boba Fett helmet with horns on it. Can we create that?
You can.
Okay, see, that's the best part about 3D printing, isn't it? You can create whatever comes to mind.
I think I saw one of those the other day in the office, actually.
Really?
That's right.
Really?
Yeah, you can.
See, I thought that was the first one to come up with that.
There's tens of thousands, but then what you can do, you can take that and you can meld it with something something else that someone else came up with and come up with something brand new.
Yeah.
I've seen people, you know, there's a whole group on Thingiverse that they take different animals and they create other animals together, and they make these weird statues. So I've seen a dolphin kangaroo, which is really interesting. You know, a little bit scary at the same time.
Not to compete with the liger chimera.
Not with that.
I think because the way that these printers work today, we can dream, we can come up with these beautiful new products, whether it's how our houses look or how our cars look. It's going to be this, the next 10, 20 years, we're going to see some wonderful imagination.
We're all dreamers, right? Everybody's a dreamer. And the thing is, a 3D printer gives you the tools and empowers you to take those dreams and go the one extra step and actually hold it in your hand. So many of us are held back because of fear, right? We have great ideas. Even though we may not be engineers or designers, we have great, incredible ideas. But how do we get the idea into something that's tangible that we can share with everybody else?
Is that hard today? I kind of worry that trying to use this software is difficult.
It is very easy. It's so simple. We're doing something with schools, not just here in New York, but all over America. So we have this thing called Makerbot Academy. We're trying to get a desktop 3D printer in every school in America. We've actually got 3D printers in a lot of schools here around New York. And so this is all part of the curriculum in a lot of these schools. So children in junior high school are printing things. They're designing and printing things in the classroom. And so it's very easy.
That is so incredibly important, because as I kind of look to the next generation and what makes them tick, we are unleashing imagination on a level, it's what you said, that we have really not before seen, because we always talk about innovation, we talk about creativity, but we always forget about the power of imagination. And 3D printing really can act as a vehicle to unleash it.
It's certainly delivering on the idea of being able to print houses right now. In China recently, they just printed 10 homes in a matter of 24 hours using a 3D printer to print the entire home. It's obviously it's very inspiring at that level, but how close do you think this is to becoming reality here in America?
That's a tough one. That's a tough one to answer, because you have to look at all of the second and third order consequences associated with it, because you can no longer look, you can't look at one trend in a vacuum.
Right.
So you have to look at its impact on jobs and labor, and whether that will replace any of the need to create those jobs.
Right. And you could probably, you know what, you're still going to need somebody that's going to put insulation up. You're still going to need pipe fitters. You're still going to need electricians, unless we can print those along with the buildings at the same time.
That's really the question. You know, Erica mentioned different materials.
Right.
So what if you can print conductive materials, right? What if you can print in 5 different types of materials? Conductive is a big one, because then we can print circuits, we can print wires, we can print logic into our circuits. And so that we're no longer bringing all these different pieces that are manufactured remotely and then brought together and assembled. We're printing them all at the same time.
I feel like the impact in the medical field, though, you brought this up earlier, seems to be the most positive effects right now. University of Michigan researchers actually helped save the life of a toddler, a very young child who had, I guess, needed a trachea stent. Yeah. Okay, you saw this story as well? Okay, and so this trachea stent needed to be customizable and needed to be made very quickly, and the best way to do that was with a 3D printer. Are there other applications you see in the medical field other than this?
Oh, absolutely. What's happening is so tremendous and very, very exciting. One of the first, and it was debuted at a TED Talk several years ago, one of the first organs that was 3D printed was a kidney.
Right.
And it was because it was the easiest to print, a filtration organ. But then when that migrates to printing heart cells and lungs, and even 3D printed skin and eyes and ears, it starts becoming very exciting. I even think of a future where maybe plastic surgery will be rendered obsolete when we can 3D print ourselves new faces. It starts getting very cool.
I'm excited about the 3D printed limbs. You already have American doctors flying to war zones like Somalia and printing limbs on the ground for these poor children who've been affected by the tragedy. And then these limbs are becoming more sophisticated. So you can personalize a limb. If somebody loses a hand, it can be personalized, and you can put that wiring, that conductive materials in, so it can move and provide sense.
Yeah, a man had a $50,000 limb, basically, and he wanted a new one, and as opposed to spending $50,000 on a new limb, he had his buddy print one for him for $50, and it looks beautiful, and it works wonderfully.
Yeah.
Today, you can go onto Thingiverse right now and download the model for RoboHand. RoboHand is a prosthetic, and it's customizable to any size hand. So it was originally developed for children, and children grow so fast. And these prosthetics, right, you can't keep up with how fast the children grow. And many people can't afford to provide these with the traditional methods as they would otherwise. So the only way that many of these kids can actually throw a baseball is because of 3D printers, and because 3D printers are so affordable that the prosthetic limbs are now allowing them to do things that they wouldn't be able to do otherwise.
And Erica was talking about plastic surgery, and I wonder whether, I'm sure we'll see people experiment with their form, how their ears look, how their nose looks.
Yeah, we're going to be these cobbled together humans, and you even think if we have the ability to 3D print organs, what's that going to do for the future of organ donor lists?
Well, it's certainly helpful for newborns as well, isn't it? I mean, that's where you can almost, it's almost impossible to find organs for newborns. So being able to 3D print at that level has to be inspiring. There is a doctor in North Carolina, Dr. Anthony Atla, who is working on bioprinting organs. And what I thought was really cool, yes, it is actually 3D scanning a wound and then printing cells to repair that wound immediately. What does that do to the battlefield? What does that do overseas? I mean,
what does it do to the sport field? So, you
that's
know,
another great point.
people repairing the cartilage, you know, in their knee. There's lots of people who have that damage from playing sports. And today, machines can begin to print that cartilage.
But do you think that at some point, because these 3D printers are going to change the way that we use some of these prosthetics, do you think it's going to change maybe even the pricing of the medical field that seems to be rising out of control, right?
Oh, absolutely. I mean, when you can manufacture the prosthetic in the hospital the same day that you've scanned someone's knee, the cost of that goes down. You don't have to transport this. You don't have to have all the infrastructure and all the resources that are required to make sure that this is manufactured and then brought to the hospital in a timely manner. You can manufacture it right on site. And here's the other thing. Let's say you make a mistake, right? If you make a mistake and something was manufactured in Texas, but you're in North Carolina, then you have to go through the same process again. With a 3D printer, if you make a mistake, you throw it out and make another one.
If we have the ability to 3D print smart nanobots that can be directly put into the body and have the ability to self-replicate on their own, this could undoubtedly usher in an entirely new era.
I want to talk a little bit about 4D printing because this is something that is, it's really unique. The fourth dimension being time, and Erica, you're the one that really introduced me to this, this concept a couple of months ago. It really is mind-blowing because it's basically the idea is you're going to be able to print objects that can change shape based on whatever activation energy is thrown in there. The guy who created this and the man is at the charge of this, this research lab at MIT is Skylar Tibbetts, and he took us on a little tour of the lab at MIT. Let's take a look.
I'm Skylar Tibbetts. I'm the director of the Self-Assembly Lab at MIT's Architecture Department. Printing started as a collaboration with Stratasys, and what we were trying to do was basically take smart materials and combine that with 3D printing. So printing materials that change shape, change property, or change appearance. So it's sort of like robotics, but without the wires and motors. We said 4 because we wanted to add time. So printing objects that transform over time.
What's most exciting about this for you? Is it coming up with the end product or figuring out how to get there?
I like to be able to invent and have the abstract and knowledge discovery and wild ideas and create the future, but I also like to be able to find ways that those technologies can be implemented to have real-world applications. We have a different pair of shoes for everything we do. And so therefore, can you have walking shoes that turn into running shoes that then create support when you're playing sports, or grow cleats when you're on grass, or waterproof when it starts raining, or breathable when it's hot. You know, adaptable shoes or garments or equipment that help us perform better, but also respond and adapt to the fluctuating environment. About tires in the automotive space, that we have a different set of tires for everything we do, like off-road tires, winter tires, racing tires, etc. And if you change the either property or shape of the tire, you get more or less grip.
Do you have a goal set in mind for this lab at this point? Or is it just let's go out and discover?
I try to look at it as half serendipity and half by design. You know, a lot of times we get lucky, a lot of times we get surprised, and you want to foster that coincidence, the chance, the excitement. And then the other part is that we want to design it, and we want to design and invent the future. And so part of ours is just, if it seems impossible, let's do it. Let's try to invent the future. If we have no idea how to make a material change shape, or if we have no idea how things could assemble themselves, let's go for it.
Hi, Skylar Tibbetts. Eric, I'm going to ask you as a futurist, you're the one that turned me on to Skylar Tibbetts. I thank you for that. But
anytime.
What's your take on 4D printing?
It's so exciting when you think about the fourth dimension being time and overlaying that in terms of what's happening with 3D printing. I think one of the most exciting areas for me is when you marry it with some of the things that you were talking about, Piers, in the health space. If we have the ability to 3D print smart nanobots that can be directly put into the body and have the ability to self-replicate on their own, this could undoubtedly usher in an entirely new era of smart pharmacology, personalized medicine. When you look to a far-out future, that starts becoming very interesting.
Yeah.
On a different level, Skylar was talking about fashion in the video, and you know, 3D printing is bringing in that whole new level of experimentation when it comes to fashion. New dresses, new accessories. Now, if you put some of that sort of smart material into the fashion, colors change, the dresses move. So we're going to see a whole bunch of new ideas come through.
All the work done with materials. So you know, Skylar mentioned he worked with Stratasys. They are doing so much work with different types of materials. And I could tell you that the area for materials research in 3D printing is just growing very fast. And I've seen a lot of amazing things. So really, when I see Skylar's work, which is just incredible, as a product developer, trying to get this technology into something that's affordable for all of us to buy and use and actually experience what he's experiencing in his lab, to me, that's exciting because I say, wow, look at this material. Now, what can we do with it? How can we actually make this at a scale where everybody can have one in their homes? So I'm excited about what he's doing. I want to see where it goes. I think that this type of material, this type of technology, will undoubtedly be in a desktop 3D printer.
What do you see as the biggest challenges? Because right now he's obviously working at the research level. This is still a 5 to 10 year out kind of a process, isn't it? Is the biggest challenge creating the material?
Once business sees that, they're going to take it and use it. There's so many advantages of using this technology.
Like so many other technologies, where does it start? It starts in the military, and the military is already starting to use it because 3D printing is not enough, because it's cumbersome. But if they can 4D print, and kind of to your point about clothing, if camouflage can change color, or if there is a crack in the road that would inhibit troops from getting to where they need to go, and they could fix that, or they could fix their machinery or artillery using 4D printing, it'll happen first in those circles, and then like everything else, it will trickle down into business and mainstream.
I think in most cases, I would agree with you, but I think in this case, I think it'll probably be most accessible to the maker group. And since they already have those tools, I think they'll get their hands on it and start playing with it first before the military invests the money and the resources into developing a big product. We've seen this a lot with a lot of the materials, especially in the maker space. And we have a lot of maker events that go on here in New York. But as soon as that material is available commercially, someone in the maker community will buy it, they'll use it, and they'll post blogs about it.
And business wants to have technology that allows them to customize their products. So every customer can have a slightly different product. So I can really see, you know, a strong interest, and a lot of this kind of development being driven by business.
I really think the only way that we will be successful exploring other bodies in our solar system will be by leveraging 3D printing to use the materials that are already there to create something that's useful for us when we get there.
All right, lightning round. I want to ask you, just shout it out here, when will the following 3D printed items become available to us? Soon, the future, or never? Food replicator, like we saw in Star Trek, or Cloud Atlas.
Soon.
Soon.
You think that's soon?
Hot dogs are soon.
Yeah. Cakes, chocolate.
That's a replicated food, isn't it?
That's right.
I mean, pizzas are already being created.
Yeah.
Pizzas are already being created, as a matter of fact. You're right.
Yeah.
We actually had video of that. A house printed machine, or I should say, I'm sorry, a house printing machine.
Sure.
That prints the entire house.
I think pretty soon. I'm not too sure how you feel, but...
Future, as future, of course, so how do we define that? I would say absolutely, but in a much farther off future, maybe 15 years.
Yeah.
Oh yeah, I think we're definitely going to see 3D printed houses.
From a biological standpoint, biological organ printer, where do we see that? Soon, future, never?
5-10 years?
Wow, that soon.
Soon.
Yeah.
We've already 3D printed ears.
Right. Princeton, 3D printed an ear. That's right, the students there. All right,
Yeah.
a moon base, a 3D printed moon base.
Soon to future. And we know that NASA is developing a 3D printer that can use lunar dust to then create replacement parts. So if it can already do that, and it has these god-awful pizzas that the astronauts are eating, then a moon base is definitely within the realm of possibility.
I really think the only way that we will be successful exploring other bodies in our solar system will be by leveraging 3D printing to use the materials that are already there to create something that's useful for us when we get there.
All right, extinct species. Do you think we'll ever be able to 3D print an extinct species?
Yes, and I will tell you why, because recently scientists have been tinkering with DNA in order to revive extinct species. So when you couple that with being able to 3D print DNA, then the combination of the two does kind of ignite that possibility. Will we is a different conversation. That's an ethical one.
Yeah,
But can we?
You're
We
shaking
might.
your head
I'm
here.
thinking, I think it could be a very future-forward thing. You know, I
Yes,
understand.
but I'm not saying never.
So far, we've not said never yet.
Yes.
All right, human replicator. I mean, I loved it in The Fifth Element. Do you think it could become reality, Pierce?
No.
Not at all.
Don't see how it could work. Too complicated,
The human body is just too complicated.
I feel.
Are we talking about the complete human body, including the
Full
brain?
human. Yeah, absolutely.
Then I would say no. I would
Okay.
say no only because what makes us human, and this starts getting a little philosophical, is the mind, which is separate from the brain, and consciousness,
Right.
which we don't know whether that actually resides in the brain. So
Can we get Dr.
print that?
Michio Kaku on the
I know.
line for us real quick?
Right.
All right, finally, robot overlords printing other robots to come and take over.
Well, come and take over. Maybe help each other print more robots.
Okay, okay.
Right.
All right, we'll just leave it at that. Then.
Yeah.
We're not going to fear the
Let's not-
T-1000s.
Don't give them any ideas.
Fantastic job, guys. Thank you so much for breaking down 3D printing for us so much. Piers, Erica, Bill, you guys were outstanding. The time went by so quickly, and you taught us a lot about 3D and 4D printing, so I want to thank you guys so much.
Thank you very much.
Thank
Very
you.
good.
And
This is
awesome.
fun.
Thank you. Thank you.